Hello, just checking my voice. Right. Zoom recording, just because I'd like to make sure we have recorded some stuff. I wanted to find out, first of all, if any amount of clarification we need for homework 5 and homework 6. The reason is that the slides themselves and what we covered in the lecture, on the recorded lectures, cover homework 5 and homework 6. I talked about them briefly before. This is the Dear Data project. So essentially, you make a postcard, double-sided. One side has the visualization on it. The other side of it has the instructions for the visualization on it. You'll be given, around the time, you'll be given a particular number to a unique number that you are, to identify you and the person you are writing to. You will write a postcard to that other person, and then you will upload images from your postcard onto CU Learn, and then we pass those images off to the other people. That hopefully making sense. It's so much cooler when you actually get the physical thing. I wonder if I actually have the one of the physical. I probably don't here. I thought I had it. Oh no, it's downstairs in my bookshelf. But like, they're just physical postcards. They're pretty awesome to get a big pile of these things. But try your best. It still comes across. If you put in the work, it will come across every once in a while. I think the first time I did this, we had some students that just sort of, I don't know, give up on the course, and they were passing in like a 8.5 by 11 sheet of paper that was drawn in pen, and you're like, no, that is garbage, right? Postcard size approximately. So get a recipe card, something like that, and you should be worried about. You're trying to do a high quality job on this. Don't kill yourself over it, but at the same time, it means multiple sketches before you do it. You don't just start with your final version of your visualization. Okay. Project 4 is coming up, and project 3 was due today, which is data cleaning. Did anyone have any open questions for project 3 before we get going? So that's, and project 4 is like, do what you would have had to do anyways, right? So project 4, there's not really much to discuss about it, but I'm more than happy to handle any questions. But I wanted to check how project 3 was going and how project 4 was going. So does anybody have any questions about those? Let's see if I have a chat thing. Okay, nice. Nada? Zip? Zilch? Or your microphone's off? So I'm hoping project 3 went well. I'm going to be looking at those soon. Project 4 should essentially be do the stuff you need for the back end. And that seems, I'm hoping it's not too crazy for you guys. This is the reason why we had to make sure we had your plan of attack before you went into it. Because if you are trying to hit a moving target, this is going to be a very bad time for you guys. So if you're not sure about your project or where it's supposed to be developing or how you're supposed to develop it, right about now, you should be trying to scale everything back. So if it's a back end feature you don't need, get rid of it. If it's going to take too long to scrape some particular website, fake the data if you need to. Like, you can talk to me about this, and that's actually what I wanted to do at the very end of this. This is meant to be a relatively short lecture. Most of the stuff was covered in the videos, so this is meant to be a relatively short lecture. I'm just going to go over your in-class submissions, and then we're going to look. Then I wanted to chat with each of the groups, maybe one at a time, see which group wants to go next. I'm wondering, maybe we can just get like sort of an arbitrary order for this. And then we can go like just checking in what each of the groups had. For the documentation, it's so I'm going off of memory from what P4 I actually gave for instructions for P4. From my standpoint, it probably is like a page of notes of what technologies you were using, what kind of thing you were doing, that sort of thing. What kind of architecture you're using. Here's an illustration of the kind of, if I doodled out an illustration of how my architecture works, doodle that out. The big thing is, do you actually have it? Ideally, for P4, if you have a backend that we can directly access, then the TA and I can actually look at what your code is actually doing. Ideally, you would have something that you can actually test how it works. So if you, let's say you have a SQL server that's up and running, and you give hooks for how to call things, or a web interface, or whatever the case, something, whatever your individual project is, it would allow us to look at what you're doing. That would be the ideal. That may not always be possible. So I know for Group A, for example, their back end is probably not going to be. They're making Tableau or Cognos, is it? Visualizations, but they would need to have cleaned up their back end and be able to access that file. So if they provided a link to the file that they're using for their back end, that would be fine, right? That would tell me what the data looks like. If you're talking the group that's looking at is group C, I guess. I don't remember the numbers anymore. It's the Data Avengers group. If you're looking at that, if you're looking at your data, I would expect to see the data you're going to be using for your statistical tests, for your oh my God, I'm trying to remember I'm trying to use all the cool, fancy, hip lingo for consumer price index, CPIs, right? That sort of thing. I would like to be able to either see that data or know how you're accessing that data. If it's stored in a database somewhere, and or you're storing it in anything other than a flat file, maybe provide some kind of hooks for us to be able to look at things, right? It's not meant to be, this is meant to be, you had to do this. Normally my students would be doing this and not getting any grade whatsoever for it, because the back end stuff was not the point of the course if it's a visualization course. And in that case, you wouldn't have that as a deliverable. This is just meant to be a deliverable, like a free deliverable. Do the thing you would have to do anyways for your assignment, for your project. Okay, and then we'll call that P4. Does that hopefully answer your question? So ideally, providing documentation or links so that we can actually look at what your data looks like, and it's more persuasive in the fact that we can actually look at your data, and also that your data is hooked up correctly. Because if the professor has to be able to look at it, it means you probably polished it up a little bit and cleaned it up a little bit. Hopefully that helps. All right. I want to look at optical illusions now. So let me bail on this, and then we'll talk about the projects. We'll probably just go in order of the, let's see if I can get rid of that. Okay. And maybe in order of the projects. So there was only one in-class deliverable for, and this, I realize, I apologize in advance on this one. The HumanFactors lecture was a lot of lecture for little exercises. Yeah, I fully admit that. But you guys came up with some awesome optical illusions. I'm used to seeing these really, they're all like color-based ones where you make your eyes bleed, but a lot of these are pretty awesome. Like this one I didn't even know about. So Adrian, do you want to just briefly summarize what's going on here?
Yeah, sure. As you can see in the first line that I wrote, I like this optical illusion, but it makes me sick to look at. So I'll
so look away for
very
a while.
quickly. So basically the whole point is that there's gray lines going side to side, like very thin ones. And the optical illusion is that they look like they are kind of narrowing down, like they're not parallel to each other. But in reality, if you remove the black and white kind of segmented lines that are going top to bottom, you'll notice that the gray lines actually are parallel to each other. And it's because that the black and white lines aren't perfectly lined up that it makes it look like they're not parallel.
And your eye automatically forms patterns whether you want to or not. Very nice. I've never seen this illusion before myself, actually, so I love this. This is pretty awesome. Is there anything below? No, there's nothing below it. Quick, let me see here. Which one was this one? We have some awesome ones. The usual Rubens vase. That's the classic. This is what did I call it? I even use the term during the lectures, so I'm just trying to remember, where you can dichotomous viewing of things, where you can see both the vase and then you can switch your eyes and see the two faces and switch back and forth. Some people naturally see the vase, some people naturally see the two faces. It depends on, and I've never seen this version of it. Those people's faces are different than what I'm used to. But you will find Gestalt principles, you will find shapes and patterns even when they're not there, because you're predisposed, your visual processing is predisposed to find shapes and objects. That's why human viewable, when we look at visualization soon, we'll talk about human identifiable objects we're being predisposed to human identifiable objects, and therefore it'll actually help with memorability of a visualization. It also is considered chart junk by Tufte, so it's a open point of debate. Oh, this one. This one freaks me out. I cannot not see these things just sort of spinning around like a bunch of snakes. Well, they're actually meant to be a bunch of snakes. Philip, do you want to talk about this, or this is just you don't want everyone else to hallucinate like I'm currently doing by looking at this?
No, it's okay. It's basically says that when you see this picture, you tend to move your eyes constantly. So what happens is that the images crashes to your retina in different places. Your brain processes differently black and white than yellow with blue. So this shift of time that you take to process gives the illusion that it is actually moving, because your brain is it's locating the spots in different places. But if you, for example, you can just focus in one point, after a while you will see that the picture actually is not moving, but it's because of the time of processing colors.
Not just time, though. Notice that your fovea has more cones, rods. Right? I always mix the two up. So cones for color, rods for black and white. Okay, so more cones. So you see color in your fovea, but you don't see much color outside of your fovea. The center point where you look at things can see color really, really well and has way better accuracy. And then as soon as you go outside, it gets a bit blurrier. And so as soon as you also do that transition to less high fidelity stuff, you're seeing more in black and white. You're seeing more shape versus actual color and categorizations. And you're also getting some of that optical effect as well from that, because it's on the outskirts. And then because you're moving your eyes around, it's also giving you some of that optical illusion as well. Nice. By the way, you were talking about that two processing system. We also talked about that during the lecture, that we actually have two visual processing systems, one for essentially for brightness and contrast, and brightness, lightness, and darkness, luminosity or luminance, depending on how if you think luminosity is not a grammatically correct term. And the other is for hue. I love this as well. That's you piecing together things, because you actually see by saccadic eye movements. Because your eye is moving to piece together things, you can trick your eye into getting these impossible illusions, because you're filling in the gaps. And as soon as you move to the other part, you forget some of your visual memory is forgetting the thing you just saw. Anyways, what I was saying earlier, the two visual processing system means that you actually see shape, you identify things differently than identifying shape, which is weird, right? You will identify the name of something by hue. You will identify the shape of something via color contrast. You read via the brightness, lightness contrast, not the color contrast. So you can have a red and a green, or a red and a blue, or red or whatever color, as long as they're the same brightness level. It is really hard to read that text, because you will read with one system, which is brightness to darkness difference. That's what you're seeing. And you actually identify objects with the hue. Meaning, if I'm going to color my bar charts and I want them to be identified as different categories, I want to use hue, because that's how that part of the visual processing system works. If I want to identify where the bar chart is and to be able to read where the line is, I need lightness to darkness contrast. So I don't want, a background that is exactly the same color as the bars. I need lightness to darkness in the bars, but the difference of the different bars, the hue is just fine, right? I need to be able to see the shape of the bar, and I need to see the different hues, and they're different fields, different systems, and that's how you actually end up having to design most of these things. I just find this stuff awesome. I get really nerdy about this. Okay, Escher. Hasna, do you want to?
Yes. So I find this one really interesting because when you look, as you said in your lecture, so when you just focus on one part, you can just focus on one part. So as I was looking at it, I mean, the first look, you don't understand the thing. But when you go like deep, so I circle some of the circles that can give you an idea that this is not a normal picture. So although they are so close, for example, the people sitting and the people like going up the stairs, they are really close, but you won't get it unless you pay attention. So it shows how small that focus of like the eye is. So you have to like pay attention to the door, like where the door is, like the people is going this way, the door is this way. So that's gives it like that you understand that there is something wrong with it, but by just looking at the whole picture you don't get it. So yeah, what I understood, it was the span, like the
Fovea?
the space that you can focus on is really, really small.
It's extraordinarily small, but it's incredibly accurate, that one little part that you can see. By the way, notice what we're doing here when you look at this guy right here. This guy right there, I'm assuming you guys can see my mouse. This guy right here, you automatically interpret that staircase as being going down. And then you look here and you realize the other side of the staircase is being used. But at the same time, if you look at that guy, you cannot help but automatically interpret the staircase as going a particular way because of the context of the information exactly where you're looking. You don't get this.
The eye adapts. It's like the way of seeing it. That's what's interesting. Like as you mentioned, when you look at like the guy on the bottom of the stairs, you automatically change your view, seeing it like from going up to down, but the other like going down from the top. So it is really adaptable, and putting like different parts together, the mind is putting those parts together, making it so normal, but it is not normal.
Well, if we didn't do that, we'd have a giant blind spot in everything we saw. And on top of that, you went on a roller coaster or drove your car, you would just be blind. You wouldn't be able to do anything. If your entire world was not able to shift and change on a regular basis this quickly, you couldn't drive, essentially.
Yes.
And so this is something, interesting to look at. Did anyone no one gave me anything with a visual? I found it interesting to have, there are optical illusions that only work for people that have, let's say, red-green color blindness, for example. In the class exercise, it's a red-green colorblind test, but the opposite. Normally with a red-green colorblind test, you ask people to see what number they see, and they say it's this. And for that example, the only people that can see anything at all, so I'm guessing that there's something there. It's just like they could be pulling my leg for all I know. The only people that can see that are people with a particular kind of red-green color blindness, right? There's some really interesting optical illusions in that way, just to make it a bit less, what my view is the only way of doing things. So what was the rabbit again? Oh, it's a rabbit or duck? Yeah, rabbit or duck.
Yes, rabbit or duck.
Yeah. Have you seen the episode of How I Met Your Mother called Rabbit or Duck?
No.
Well, good episode if you want to have a look at it. But anyways, it's an episode of a TV show called How I Met Your Mother, called Rabbit or Duck, season 5, I do believe, 4 or 5. Anyways, so talk me through it, or what did you like about these illusions?
So basically, I like where I can see patterns in the pictures. So what I can see is like there I can see a cutted tree, but it's and then there's a tree behind. So if you look at it, at one shot you will see it's one tree. So and then when you and then similarly, if you look at you will first see it's a rabbit, and then the second shot you can see it's a duck. So these are basically like how your brain receives one visual at a time, or we can say how things are, your brain perceives things as how close they are. Yeah, that's it.
And again, that automatic shifting, because I honestly was wondering what this image of the tree was for, because all I saw was one tree that was chopped in half with a fence. I'm like, it's just photoshopped. Like, what's special? Until you realize it's actually a stump.
Yeah,
there's another tree behind it.
Another behind the fence.
Nice.
Yeah.
Nice. Thank you. All right. Do we have one last one? And then and Tina's. Oh yeah, Tina. Do you want to walk me through this one? This one was awesome. I've never seen this one before.
Yeah. First of all, I find a TED Talk. It was for Dr. Buluto, and it was about optical illusions, and it was very interesting. I highly recommend watch this TED. And the second one is when you stare at the center of the picture, after a while the picture completely fade, and it was very interesting for me.
Oh, yeah, it just completely fades away. There's also cases where, like, you see an inverted American flag, for example, and you stare at it, and then you look away, and then you actually get it. Opponent process theory. Opponent process. Essentially, you get the exact opposite reaction. Because your retina was your eyes were so acclimatized to a particular color scheme, you see the exact opposite color when you look at a wall or white wall afterwards, because it's just, you get your neurons suddenly switch over. It's also why people like going on roller coasters, because you get a different.
Yeah, and it is an visual effect named Troxel effect. And it's I think it's discovered by Troxel. I don't know what was the scientist's name.
I'm assuming it's Troxler.
Yeah, Troxel, and it was interesting.
I think it's extremely interesting. I'm trying to think of the other. You guys are all too young for this. I think there's an episode of Friends about it, if you've ever seen that show as well. Anyone seen one of those 3D posters? They were a big fad back in my day, like back in the Stone Age. It's a 3D poster. It's essentially a bunch of dots. But if you we
have something like this in our weekly magazines. At the end of the last page, we have some pictures which are 3D pictures, and we put them, we stare to them and try to see what is the 3D picture.
Now that's doing something slightly different. It's using stereopsis, your two eyes, and using that to sort of make that fake image. But I just like to point out the fact that people are going to see things whether they're there or not. There's all sorts of ways you can be mean or horrible about cheating with a visualization. There's also ways that you're trying to protect people from seeing the wrong thing. And it's sort of what part of your role is to try not to lie to people through a visualization, because it's too easy. It really is. It's really amazingly easy to just cheat and lie via one of these visualizations. So just something to think about. Very nice. Oh, there was a comment, so I want to just see that, and then we'll move on. Okay. Autostereogram. Okay, nice. Thanks, Adrian. Which, in case, so just to see if we can. There you go. I can't show my screen, but you guys can see this, I'm assuming. Oh, I can do that. All right, and if you stare at this, if you stare through the image, most of the time I needed a big image in front of me, you will actually start seeing 3D things. I had some trouble with that for a while. So the weird thing is, much like red-green color blindness, there are actually people, I've met numerous people in my career, academics that I'm working with on a day-to-day basis, and I had bring them in for a user study. For example, I asked them to do a 3D what's called a stereo fly test. It's a 3D image. You put on these special glasses, 3D glasses, and you ask to pinch the fly's wings. When you put on these special glasses, the image of the fly looks like it's three-dimensional, and you pinch the wings. And you'll give it to some of your colleagues, and they'll go, "What do you mean?" And they'll just poke the fly, and you're like, "What are you doing?" Like, they don't know. They have no stereopsis. They do not actually see binocular images. if anyone that's had a lazy, if any of you guys have had a lazy eye when you're growing up, you probably don't see stereopsis either, or you have more trouble with it. My wife did not have a lazy eye, but she can't see stereopsis for some reason. When she did her driver's test, they're like, you're completely wrong. Like, it's amazing that we make up the world that we're seeing, and we don't even know that we don't know that we're seeing the right thing. It's kind of freaky that way. So nice. So did anybody have any questions about any of this stuff? So for example, and I want to make sure that I did color right with you guys in the lectures. So when we're talking about, for example, how we perceive color, what we end up getting is you'll see the way you know that something is blue is that it's not red or green and it's bright. That's blue, right? For humans, which is a weird concept. Otherwise, it's yellow. Okay, so we actually sorry, blue. We actually recognize blue, but the red and green are not being stimulated, so you would see blue. If the blue is not going off and you see red, a bright color, then you see red or green. And yeah, we have specialized things for red and green. We're pretty good at that one. And brightness is just how many of those cones are going off and how much your rods are going off. That's how we see light. But we don't see it that way. It's this composition of very fundamental, small, low-level things that we build out from there. Much like when we're talking about machine learning, it's like you got a bunch of data, and eventually you find a pattern if you put enough data in there. And so we get things like this optical illusion where this right here is the exact same color as this right here, despite the fact they look radically different because we have color constancy. Or how many people actually see a yellow and white dress, by the way? Does it? Oh, Hasna, you see a yellow and white dress. Okay, I cannot see anything but a blue and black dress. It makes no sense that anyone sees anything other than a blue and black dress. It drives me nuts. Like, what? So how many other yellow and whites do we have in here? I did the very first time, but I haven't since then. Oh, okay. Wow. Nice, right? And people went to war on this thing. They were screaming and shouting at each other. It's amazing. It's they also had one for auditory illusions. It was a fad a while ago. I can't remember what the words were. Maybe you guys, some of you remember. It was like if I stare at it, then I keep flipping colors. Most people can't do the flip. Oh, that's impressive. And it depends on your. Does it depend on your screen? I've been throwing it on all sorts of screens and I don't see any difference. White and gold, yeah. I guess is where you're looking. I'm always looking at the edges over here, not over here. Anyways, it's neither here nor there. I didn't want to start a war or anything, but I just love the fact that our view of the world is not something consistent. It is a crazy amount of visual processing right back here where my bald spot is. That's where we're doing all of this. So all the we have all these neurons, your optical nerves goes to the back of your head and you do a bunch of visual processing up to the top of your head where it's starting to connect to your motor cortex, which is up on the top here. Your interior part would be a lot of your language processing where you're identifying individual objects. And so we get what you can do with it, how you identify things. And that's their two visual process field. So when we have something like this, right there, I couldn't get it. It's very hard to get it exactly right, but you're trying to get two colors that are the same brightness level and how hard it is to actually read. And when you make it larger, it gets even worse. But I have friends that when they go strawberry picking, they have to rely on their kids and their wife to help them strawberry pick because it's just guesswork at that point in time. Strawberries don't pop. For if you're red green colorblind, it's just a big bunch of green and you don't know what you're picking. You're picking white ones, you're picking red ones, you don't know what you're picking. Because you can imagine there's a evolutionary benefit to being able to see color for ripeness of fruit and identifying ripe fruit. That's the best I can guess for this, but it comes up in all sorts of weird, wonderful ways. So when you're talking about your project, you drop in the word luminance, saturation, or hue would make my heart go a patter. It would be very impressive to you talking about that. So luminance is brightness to darkness. Saturation is how the brightness to darkness doesn't change. It's just how blue, right? If you have a sort of a, you know, those, when you talk about a color and it's not really saturated, but sort of like a, oh, it's one of those brown walls, or those blue walls where it sort of looks kind of dirty, but not quite, it's not vibrant at all. That would be low saturation, like this grayed out kind of blue versus a vibrant blue. And then your hues are your different colors of the rainbow. And they are treated differently and should be dealt with differently. Is that a comment on my lecture? Yes, dull is the right term for it, Jacob. You're right. So this is the kinds of things. And notice though, this is the scale data. We could order those colors, right? Luminance, I could put them in a particular order. That's why they work for ordinal data. They work relatively well for continuous data and ordinal data. They're not great for them, but they allow you another dimension to show in your data. You can't use hue, and people keep trying to use hue for ordinal data. It doesn't work because you don't remember what. Tell me the colors of the, you know, if I ask you the colors of the rainbow, unless you memorized it, what comes first? Blue, or like if you go from red to ultraviolet, what comes first, yellow or green? I don't remember, right? It doesn't stick in your head because it's not sort of your natural processing. By the way, and if you want to make sure your thing works for people with red green color blindness, there's all sorts of ways, but Color Brewer and a number of these websites can actually test your visualizations or test whatever interface you're looking at. There was a comment here, and then I'm going to let. Yes, that's exactly right, Jacob. Like the alphabet, right? What comes first, the L or the LM? Okay, that's fine, but I and M. I always have to, you're singing the alphabet song in your head every time. And that's a bit more acceptable than color. But so one of the big rules is change it to black and white, see if it works, and then change it after, then change it back, add your color back. Oh, so what are you trying to do with the colors? One of the other issues that we have is color is very cultural. If you are from China, red means something very, or traditionally would have. It may have sort of this colonialism crap might have actually affected a lot of Chinese culture as well. But Chinese culture traditionally has red as a very lucky, good color. And then you come to North America and it's a terrible color, right? It's the color of your stop sign. It's the color of your red light. It's the color of emergency. Oh my God, you're going to die. And so it depends on the culture. It depends on a lot of things. There is some learned association from a cultural standpoint. It is, I would argue more that it's not the color per se that you have to worry about. It's the not overdoing the sheer number of colors. So you can use hue and different shades, but I wouldn't go. You can imagine if you're trying to change your hue and change your shades, you're not going to be conveying information very well because you're going to get this. You're not going to get a pop out effect. So you can see different shades of blue, but if you vary the shades of blue and shades of green and shades of red and like if you do a whole bunch of hues and also try to do the saturation level at the same time, people aren't going to see your data. It's not going to pop out. Yeah, all things color does not pop out essentially. And normally luminance is, if I want luminance, I want it for seeing the shape. And if I'm using hue, I want it for different categories. That's the general rule, right? Hue is great for categories. People are really good at identifying things by category with hue. We do it naturally. And as soon as you try and do anything else with it, we have a hard time. So this, terrible, terrible, terrible. Now, these are different categories, but what else do we have going on here? The kiwi is orange. The melon is yellow. The orange is purple. The peach is green, right? You could have mapped it somewhat to the actual fruit itself, because you're also fighting your knowledge base. Like when you see hue, it's for when you see hue, you get it's used for identification. So you see orange and it says kiwi, you know the color of a kiwi, even when you don't, even if you know it, even if you know that there's a problem here, you're fighting against your visual processing system. You see you see the color orange and it says kiwi, right? If we labeled these just different colors and we said yellow, this was green and this is orange, and the color is different than the actual word, you would have the same effect. It feels harder to get your head around it, even if you don't quite identify that issue. What was the other chat in here? Yeah, we also have blocking data using 3D, and also it has a transparency. And on top of that, you have a perspective that actually is making this smaller than this, despite the fact that this yellow up here might be the exact same value as this right down here. There's a slew of garbage in this visualization. This is why we use it. We like making fun of people. One more thing. Okay, life factor, and there's a waste of ink. But I'm not as much of a acolyte of Tufty as a lot of other people, but I even love this thing where it's just, notice rainbow color mapping because it's 3D and it's normally considered acceptable. But if you switch it up to a different color scheme, it means that A, you know if it's right or not. B, you will actually see where things differ because it'll work in black and white. And C, you're worried about, for an artery, for example, and you're worried about people having some kind of cardiac disease. You want to know where the problem areas are. You don't care about the other stuff. You want the problem areas. And that is identifying the shape of where those problems areas are, like just say this red patch right here. So this is a New York Times thing. Also will give you the same approach. Same thing here. And this, it hurt me to make how bad of a front slide this is, just because it's, and by the way, does anyone recognize the album? Anyways, so yeah, there, I think somebody recognized it. Yeah, thank you. It's the album. I have the vinyl downstairs, and my wife said, well, you don't have a record player. Why did you buy the vinyl album for it? So yeah, I love the fact that we can't identify those. Okay. What I wanted to go over today, I'm off the beaten path a little bit. What I wanted to do with you guys, besides double checking to make sure all that particular lecture made sense, right? That's one of the fundamental things. I want you guys to have a sense of, let me see here. I didn't keep it up there. Human factors. Okay, I didn't bring up C. There's a video that I have. Let me see. Human factors. See, cognition. Where we have change blindness, for example. We have contour detection, which is what we were getting in with those non-parallel lines, whether you wanted to see those or not. Textures and contrasts, whether we can see certain layers. And Gestalt principles are just easy ways of describing a particular phenomenon that you're aiming for. But I wanted to see if I have the change blindness in here. Oh, please let me have the change blindness in here. I love that video. Okay, it's next part. If you hadn't watched the video, please do. It's fun as hell. I love that video. So have a look at that. Besides that fact, if anybody doesn't have any questions, what I'm going to do is let's take group by group and let's just check in with how you're doing. Now you can stay on the line potentially, or if you're the last group, we can just have you come back. You can come log back in later in a second. I just want to talk with each of the groups to see how your projects are going and what kind of thing, if you need any help with your project. So, I love how Stanley Donwood's the actual person, right? because Tom York is also the co-artist on most of these things, and as a co-artist, he's using a pseudonym instead of his actual name. I'm just trying to remember. It's I can't remember his name. It starts with a T, I do believe, is for the last name. Anyways, yeah, I've been out of my Radiohead fandom or obsession for a little while because I have kids. But anyways, so let's do this. Let's have group A stay on the line. Everyone else, you can take off until you think about, I'm thinking 5 to 10 minutes per, maybe less per group, just to come in, chat with me. Then you can come back out again, or you can just stay on the line, mute yourself, and then come back in later on. I think you want messages though, by the way, because massages in the visual are different. But okay, so group A. So let me, if you want, do you want me to stop? I can stop this, the sharing. Do you want me to stop the recording just so you don't have anything recorded for what your group is talking about, and then we can go from there. Okay. Let's